Good day again. And now we are on question number 4, September 2023. That is question number 4, September 2023, which is on momentum and impulse. Let's read the statement. 2 trolleys, A of mass 1 kg and B of mass 2 kg are held stationary, which means their velocity initially is equal to 0 for A and B on a smooth horizontal surface with a compressed spring as shown in the diagram. The spring is released and falls to the ground. Trolley A moves to the right at a constant velocity. Therefore, the velocity for trolley A, after, that is the final velocity in this case, or we can just say velocity of A after they are released is 5,0 meters per second to the right. Okay, and collides with the wall, which means A will collide with the wall. Assume this is an isolated system. The first question says define an isolated system. So the system is isolated when the net external force is equal to 0. The net external force, external force is equal to 0. Then the system is isolated. Calculate the velocity of B immediately after the spring is released. So in this question, we are going to use the conservation of the linear momentum, which says in an isolated system, the total linear momentum is conserved. Okay, meaning that the sum of the momentum before is equal to the sum of the momentum after. That is before the spring released and after the spring is being released. Now this sum says, this sign says you must add the momentum. Now we have two objects, which means we are going to add the momentum of object A plus the momentum of object B. That is before the spring is released. Then finally we have the momentum of object A plus the momentum of object B after the spring is being released. Okay, now they said the spring were held, and we said the initial velocity for them is 0. That is the initial velocity, the velocity before the spring is being released. So the momentum is calculated by mv, meaning that if the velocity is equal to 0, therefore the momentum is equal to 0, meaning that before the momentum was equal to 0, then we have mv of A plus mv of B after they are released after. Okay, so let's substitute. The mass of A is 1 kg. The velocity of A after they were released is 5 to the right, is 5 meters per second to the right. Let's take right as positive, which means our 5 will be positive. So we have 5 plus the mass of B, which is 2. Then the velocity of B is what we are looking for. Then 5 times 1 is 5. Then we transpose, we have minus 5, which is equal to 2 VB. Then we divide by 2. Then we have minus 2, 5, which is equal to velocity of B. After, we can just say it's a final velocity. Therefore, the final velocity of B, finally B is moving with 2 meters per second, 2.5 meters per second. Since it is negative, then we say to the left. To the left. Okay? Then let's go to the second question. The second question says, the average force exerted by the wall on the trolley B or on the trolley A is 80. The force that is exerted by the wall. Now trolley A continued and collided with the wall. Then the wall exerted a force to A, which is 80 newtons, meaning that this force is to the left. Okay? And the collision of the trolley with the wall lasts for 0.5 seconds. So we have the force on A. We have the force on A. Okay. We have a force on A. The force on A, which is equal to 80 newtons to the left. Then we're given the time for collision, which is 0.5 seconds. We said take right as positive, meaning that left must be negative. Therefore, this will be negative. So we are going to use this formula from the formula sheet. So we are on question number 4. This was 4.2. Then this one is 4.3. On question number 4.3. Okay. So the net force is minus 80. The time is 0.5. Then the change in momentum is M is equal to mv final minus mv initial. Now we are talking about A. We are talking about A on the wall. A on the wall, which means that is the final velocity. Then we need the velocity that A came with. That was 5,0. Okay. So the question says here, calculate the velocity of A of trolley A. Calculate the velocity with which trolley A moves away from the wall. We are looking for the final velocity of A now. This becomes the initial velocity. Then we are looking for the velocity of A as final there. Okay. So 80 times 0.5, it's negative 40 in our case. Then A is 1 mass times the final velocity. This final is the velocity of A when A moves away from the wall. Then we have the mass of A, which is 1, times the initial velocity now is that 5. Okay, so we have negative 40, which is equal to 1 times Vf, so it's Vfa minus 1 times 5 is equal to 5. Then we transpose 5 become positive, So a 40 plus 5, which is equal to the final velocity of A. Therefore, the final velocity of A is equal to negative 35. Therefore, final velocity of A is equal to negative 35, that is 35. We're going to write positive 35 in this case, and we write the direction 35 meters per second. That negative tells us that A is moving to the left. Okay, then question number 4.3 is answered. Now let's go to another question, which is question number 4.4. Briefly explain what is meant by inelastic collision. Inelastic collision. The meaning of inelastic collision is that is the collision where the total kinetic energy is not conserved. Total kinetic energy is not conserved. Then we say the collision is inelastic. Okay, the total kinetic energy is not conserved. It's either the energy before collision, or in fact the energy before collision and after collision, the total kinetic energy is not the same. That is, there is a loss of what? Of energy during the collision, or there is a gain of energy during the collision. Then we are done with question number 4. Let's go to question number 5. Let's go to question number 5.